Hello everyone, we're looking at question 2 of winter 2018 paper 2 15054. The question reads, a small crack appears in an oil tank and a stream of oil is pushed out through the crack. The oil hits the floor at P, right here, where a puddle of oil starts to form. The gravitational field strength is equal to 10 Newton per kg. The density of oil is 940 kg per meter cube, and the crack is 3.3 meter below the surface of the oil, given right here. Calculate the pressure due to the oil at the level of the crack. So essentially what they're asking us is to find out the pressure that is acting on this surface. Now whenever you have pressure and whenever you have a liquid and when you have to find pressure in the liquid, the best formula that you can use is pressure equals rho, I'm going to write as RO, rho GH, where rho is your density, your G is the gravitational field strength, and height is the height. If this is the point that we have to find the pressure on, the height from the very beginning, which is given to us as 3.3, you just have to plug in the values. You get pressure equals density as 940 kg per meter cube, 940 into G, which is 10, and then you have the height, which is 3.3 meter. We do not have to convert it or change its unit because it's already in meter. And when you multiply this together, you will be getting 3.1 into 10 raised to the power 4 pascals. Moving on towards the second part, explain why the atmospheric pressure does not affect the rate at which the oil is pushed out through the crack. Now, this is the crack right here. We know that at this crack there is pressure acting due to this liquid which we just found here. And now they're saying, why does the atmospheric pressure has no effect on the intensity at which the oil is coming out of the crack? Now, we have air here, we have the air here as well. So the atmospheric pressure is acting on this part as well and this part as well, and both of them are equal. It's not like that we have greater air here as in comparison to what we have in oil. The atmospheric pressure or the air that is here is the same amount. But for oil, but the pressure due to the liquid, we can see that the oil is only on this side of the crack, not here. So that is why the pressure is only because of this oil and not because of the atmosphere. It's because the atmospheric pressure is on both sides of the crack, so it is just cancelling it out. To better understand this, think of a straw. When you have a straw and that is open at both ends, now you have atmospheric air here as well, and you have the atmospheric air here as well. So it is there from both sides and it is equal at both sides. So I can say that the atmospheric pressure just cancels out, and that is the same case here. So we will say, because, and another thing that I want to add is, when you're looking at the crack is, let's say, this is like a crack. Now the crack has this is one end of the crack, this is the other end of the crack, and these two ends are open. You have atmospheric air here as well, and you have the air here as well, and both of them are equal, and so it just cancels out. So we will say, in simple words, the atmospheric pressure is acting on both sides of the crack and so it cancels out. Moving on towards B part. As time passes, the point where the oil hits the floor moves away from P and towards the tank. Explain why this happens. So essentially what they're saying is that gradually with time what happens is that initially the puddle was forming here, but with time the puddle started forming, let's say, here. Why is that? When you have greater pressure, the oil will come out with greater force. It's like you have a bottle filled with water and you make a hole there and the water starts squirting out at such high intensity, but gradually with time you will see as the water level decreases, as the amount of water in the bottle decreases, the water that is coming out of the crack decreases as well. Why? Because the pressure that is acting, that decreases. That means initially if this was the amount of oil we had, the oil started decreasing, and let's say this was the new level of the oil. Now when this was the new level of the oil, and to understand it even better, now if this is the new level of the oil, only this amount, only this small height of oil is acting on this crack, and because of that when height decreases the pressure is going to decrease, and as a result only little oil will come out and fall here. So what we will write is that with time the amount of oil decreases in the tank, and so does the pressure acting on the crack. And this is it for the B part and for question number 2.